All right.
Oh
my.
I wouldn't sleep
All
on
right.
that no more.
Did you just get the other test?
Loopies.
We'll handle this afterlife. Oh my goodness. All right. So, section 5.3 is on graph concepts and terminology. So we're going to get some more vocabulary words. Yay! Okay. So the first thing you need to do is understand the word adjacent. What does it mean to be adjacent?
Next to?
Next to.
Good job.
Side by side. Connected. So if I put my hand on James's shoulder, we're adjacent. We're side by side. We're connected. Okay. So we've got two types of adjacent things happening in our graphs. We've got adjacent vertices. Okay. These are two specific vertices that are joined by an edge. So you have to have two dots and a line that connects them to make them adjacent. A loop is a special one. It's adjacent to itself. Okay. So, in other words, if an edge exists between two vertices, they are adjacent. So, is A adjacent to B?
Yeah.
Yes. There is a line that connects A to B. So, this is a yes.
Oh, I ain't even looked at that.
Right.
I thought you said that because it was side by side, like A and B.
No. Okay. Number 2 says, is E adjacent to itself?
Yes.
Yes. E has a loop, and a loop is adjacent to itself. So this is a yes. There's a graph right there on your paper.
Because I think it just said the key.
Oh my goodness. Gianni. Is D adjacent to A?
No.
No, there's no line that connects D to A. So that is a no. And is C adjacent to itself? No. There had to be a loop there if it was adjacent to itself. Questions on adjacent vertices? Yes, it's that easy. Okay.
CE to
Okay.
no.
In order for two edges to be adjacent, they have to share a vertex. They have to share a point in common. Okay. So, is AB adjacent to BC?
Yes.
Yes. They share B in common. AB to BC. Is CE adjacent to BD?
No.
No. Okay. CE is a completely different line. So, CE is here and BD is here. They do not share a point in common. I understand that, yes, they cross here, but that is not a vertex. So you cannot count that. They have to have it in common. Also notice, AB ended in B. BC started with B. Okay? CE ended in E, but this starts with a B. So they know they are not adjacent. Questions on adjacent edges?
Oh no.
Oh no. All right. So the part of the homework that I told you to skip because they didn't cover it
The
is
degrees.
the degree. The degree of a vertex is the number of edges at that vertex. So in other words, if you go to the point, how many lines are coming off of it? Okay. A loop is going to count twice towards your degree. So if I go over to figure 1, we're going to do the degrees inside of figure 1. If you look at point A, how many edges are coming out of A?
1.
1. So A has a degree of 1.
1.
Okay. We're going to move down here to B.
3.
There are 3 lines coming out of B. Go to C.
2.
2. We go to D.
2.
And we go to E.
3.
Ooh. How much?
Oh.
4.
Oh.
Remember, this loop counts as 2.
Oh.
Okay, it's kind of like an enter and an exit. It's got 2 pieces that touch.
Oh.
Not to mention, you then have the line that goes up to C and the line that goes to E. Or I'm sorry, D. So that makes it a degree of 4. Okay? The last little bit of the degrees. You can have an odd vertex. That's a vertex with an odd degree. So what are my odd vertices in this figure?
What'd you say? Oh, it's a vertex.
One.
Vertex with a degree.
1, 3.
I mean,
1 and 3, so A and B.
Oh.
Okay. A and B are odd vertices.
Oh.
They have a degree that is an odd number. 1 and 3. And then we have even vertex. It's a vertex with an even degree. So C, D, and E.
C, D, E. It sounds.
I think she had too much
That's
sugar
not so
today.
much.
I'm not good. You're so irrelevant.
Y'all are so sweet to each other. Okay?
My boy.
We're almost done with some key terms. Okay? My next one is a path. This is a sequence of adjacent vertices from one starting point to an ending point. So in other words, if I put my pencil on the paper, I should be able to trace a path without lifting. Okay? So there's some rules when you're creating paths. The first one, an edge can only be used once. So once you've traveled a road, you can't go back the road. So once you've traced a line, don't go over it. The length of a path is the number of edges that you have traced. Okay, so they want us to find a path that starts at A and ends at E. So we want to start here and we want to end here. So if I start at A, where can I go?
You can go to B, and then
I can
you
go to B.
Then you can go to C, and then you can go to E, and then you can go to D, and then go.
You're technically done right there.
Oh,
We just have to go from A to E.
Oh.
Doesn't say we have to cross every line. I just have to get from A to E. So A, B, C, E.
Oh, weird.
Okay? We've got a couple of them. I can go from A to B to D to E. A, B, D, E. I can also go from A to B to D to E and around E and back. So we're at A, B, D, E. I know, it's extra, right? I'm so sorry. Okay, so if I go back and look at my red path, I went 1, 2, 3 edges. So it has a length of 3. I've traveled 3 edges. When I do A, B, D, E, A, B, D, E, again, 3 edges. If I did the last one, 4 edges.
We have to do that many times.
No. If I ask for a path, I just need 1. I'm just showing that there's several ways you can do it. Okay. Notice, if I have 4 vertices in my path, my length is 3. So if I have 4, we're at 3. If I have 5, I'm at 4. So the length of my path is always 1 short of the number of vertices in my path. Okay. So keep a mental note of that so you don't actually have to count them.
Yeah.
Okay, we had paths, and now we've got circuits. So a path can start at one point and end somewhere else. A circuit, think about NASCAR, around and around, and guess what? They finish right where they started at. So a circuit is a path that starts and ends at the same vertex. So you'll notice when they ask you for a circuit, they're only going to give you 1 point because you don't have another ending point. If they tell you we need to start at C, you need to end at C. Okay, so it says find a circuit for C. So they want to start here, which means I need to end there. Where can I go when I leave C that will get me back there?
C, B, is that D over there? And the E, and back to C.
Beautiful. I can leave C. I can go to B. I can go to D. I can go to E. And guess what? It travels me right back to C.
Wait, that's not even one minute.
Yeah, sure. Stupid.
You can also do this in reverse. Okay. Because it's a circuit, it can be done in reverse. So that means I could start at C go backwards to E, D, B, and back to C.
Word up.
Okay, so that also works. What's the length of these two circuits?
Oh.
4. If I have 5 vertices, that means we have a length of 4. Find a circuit for E.
I ain't go to thing go to E to D.
E to D,
Yeah, to B
to B,
to C.
to C, to E. Okay, so he said E to D, to B, to C, and back to E.
Can you just do the loop?
Oh dang.
I could have literally taken my pencil and went, whoop,
And that full wait.
and that's a circuit.
Oh,
I started at E, and I went straight back to E. Okay, that's the shortest circuit you can ever have. This circuit has a length of 1. 2 vertex, 1 edge. And this one then has a length of 4. Question. Guess what? We're going to practice, and then I've got 1 more term. Actually, no, I'm sorry. 3 more terms.
Oh, catfish.
3 more terms. My bad. My bad. Okay. Let's see what we can do with this. Gianni, there's a graph here that we're going to use. Okay. All right.
What?
I just wanted to make sure you saw the graph so you.
Yeah.
Okay. Okay.
What?
Find a path from B to K. So that means B is my starting point and K is my ending point. That passes through W, so I have to go to point W at some point, but I don't want to touch S.
Oh, that's easy. Go to B to
B to
A
H to J
to J
to
to
W
Z.
to K.
You said B to H. That's going to be my only way over. Okay, B either loops around to itself or it goes to H. So I don't have another choice. We said we want to go through W, but not S. So when I leave H, I'm going where?
J.
To J,
What's the next?
to W,
Obviously.
and to K. Okay, so this one goes, whoops, I'm putting it in the wrong spot. So we're going from B to H to J to W, and finally we end at K. Okay, be careful with the next one because they got a little more specific. So it says find a path from H to J. So I started H, I went to end at J, and it must have a length of 4. So I need to cover 4 edges, which means I need to have 5 letters up here. So I must start at H.
So
H, K, W, J.
Hold on, hold on. I'm going to use those for a minute. H to K to W to J. That is a path from H to J. What's wrong?
You need a length of both.
That's only a length of 3. Okay?
Whatever.
1, 2, 3. I need a length of 4. So H, K, S, W,
Man,
J.
it's 4 when I write it down on my paper.
So S to W to J.
Oh wait, no, I said I'm gonna say H, then W. That's
Easy.
Okay? So please be careful. When they get specific, you must give me one of the length of 4. Okay? Number 3 says, find a circuit with a length of 5. It doesn't tell you where you need to start. But remember, it's
I'll
a circuit.
prefer to start on
So
the
you have to
D.
start and end at the same spot. And you said you want to start where?
B. Can't you start from B and then work your way to J?
Okay, be careful though. This is a circuit.
Oh.
So watch what happens. If I start at B, whoa, that's really off. If I start at B and I go across, how do I get back to B?
Oh.
Because remember, you can't cross a line more than once. So good thought, not going to work. Okay, you weren't the only one thinking that, so I'm glad you threw it out there.
Oh.
Okay, you were not the only one thinking that.
I think I got them.
So B is going to be out of commission. You can't even use it. Okay, that actually gets us into our next term. That's actually an edge. It's called a bridge. We'll talk about that in a little bit. Okay.
Oh, no.
Okay, you want to start at S. We can start at S. Okay, so we want to start at S. Where do we want to go?
No, we don't want to start at S.
Let's start at W.
No.
started at H.
Let's start at S, go to K, then go to H, then go to J, then go to W, then go to H.
H.
I mean C. I mean S.
You said S, K, H,
J,
J,
W,
W,
S.
S. So that's 1, 2,
Two.
3, 4, 5. That works.
E.
S to K to H to J to W and back to S. Okay. Now hold up a minute. Gianni said, let's start at W. Guess what? You can do that too. Watch this. So W, what comes after W?
S. K.
No.
H. J. W.
So all you can do is pick a new point that you already have here and just reorder it. Okay. So we just pick a new point and start. This is called a shift. And we'll actually talk about that in chapter 6. Because Hamilton circuits have to deal with shifts. Okay. So both of those are a circuit of length 5. You could have also started at J and went J, W, S, K, H, and back to J. You could have started at H and you could have started at K. Any of those would have worked. Find a circuit of length 1.
B.
B to B. Please make sure that you give me B to B. B is a vertex. B to B is a circuit. The last thing they want us to do then is find the degree of each vertex and label it on the graph. What is the degree of vertex H?
3.
3. What about S at the top?
3.
And J?
3.
And B?
3.
And W?
3.
And K?
3.
Whew. They're all odd. They're all odd. All of these are odd vertices.
What that add up to be?
Hurt my shoulder.
What that add up to be?
3 times 3 times 3 times 3 times 3 times 3 is 48.
Oh my
No,
gosh.
it's 36.
The fact that he just said,
18.
the fact that he just said add and you multiplied.
And then she said 3 times.
Right.
Why did you say 3 times?
Like he said, what does that add up to? And she goes 3 times 3 times 3. That's multiplication there, Zozo.
It'll be all right.
All right. So
It wasn't. It's 18.
we have 2 different types of graphs.
Yeah, that's like what's in there.
Okay. We have 2 different types of graphs. The first one is a connected graph. Okay. That's graph number 1. Graph number 1 is all in one piece. That's what makes it connected. Okay. There's edges that reach out to every vertex in that graph. Okay. Or we have a disconnected graph. Notice my disconnected is in 2 separate pieces. Okay. It could be in 3 separate pieces or 5 separate pieces, but it cannot be one big piece. There must be multiple pieces to make it disconnected. Okay. So we have a special edge. We have a special edge that makes these connected or disconnected. And these edges are called a bridge.
A bridge.
So a bridge is an edge in a connected graph that when I remove it, it makes it disconnected. Okay, so it takes us back to figure 1. It says AB. AB is a bridge. So you don't have to go back. I'm going to go back here. Maybe I'm going to go back here. Where's my...
I ain't got the actual drop line.
All right, so if I go to figure 1, they're telling me that AB is a bridge. Let me get, I need this, and I need this, and I need white. You all right there? Again, are you okay?
It's just weird.
He's just weird. I mean, by all means, whatever. Where is, I need the size of it. Oh, there we go. I need this. I need this. Okay, so what they're saying is if I take out AB, so if I would take an eraser and I would erase AB, AB is an edge because look what happens. We're now in two pieces. A is over here all by itself, and then the rest of the graph is still connected. So any edge that I can erase and it separates my graphs, it becomes a bridge, okay? So for this one, H to B, well, you're not giving me what I want here. Okay, so if I erase HB, that leaves my little loop over there all by itself, and then the rest of the graph connected. Okay, so if we go to graph 1 here, can you find me a bridge? One line that I can erase.
C to E.
C to E. C to E is a bridge. If I erase C to E, C is all by itself and the rest of it's still connected. So C to E is a bridge.
You also do E to D.
E to D is also a bridge. Again, it leaves D all by itself. There's one more.
B to E.
What'd you say? B to E. B to E is also a bridge because that leaves me a little triangle over here and then a little angle looking shape thing over here. It's two separate pieces still. So that is also an edge. Okay. They want you to find bridges in graph number 2. Okay. You only have bridges technically in the second graph. So what are my bridges in the second piece of that graph? S to W.
S to me, U to V.
U to V, W to T, T to V. Each one of those edges is technically a bridge in that graph. Okay. Questions on bridges? Okay. Let's practice some more pretty pictures. We like pretty pictures. Okay. Draw a graph that satisfies the given properties. We want to have 6 vertices and 6 edges. 6 vertices and 6 edges. So what do I need to draw first? I need to draw some kind of 6 dots.
6
Okay?
vertices.
Gianni got very specific and said a hexagon. Okay, I just need 6 vertices. Bless you. Okay, 6 vertices. I now need 6 edges. So I need to draw 6 lines. Doesn't matter where you put them. Just make sure you count. 1, 2, 3, 4, 5, 6. So literally a hexagon will cut it. Number 2 says I need 6 vertices and 2 bridges. Okay. The easiest way I can tell you to draw a bridge is to only have one line reaching out to 2 points. Okay. So draw yourself 6 points. Because everybody always gets confused with drawing bridges. Pick any point you want of those 6 points. And draw 2 lines that reach out to 2 of these separate points. Oh my gosh, that's so off. Okay. So these are now bridges that reach out to these top 2 points in my picture. So what I want to do now is I don't want to draw any more edges going out to those, but I want to connect the rest. So I'm going to connect the rest so I don't have any more bridges. So now I've got those two bridges that reach out, kind of like a TV antenna looking thing. Okay. And then everything else is connected. Question. Okay. 3 and 4 should be super easy. You just did one of these for your warm-ups. So anytime you're dealing with vertex set and edge set, draw your vertices first. So I need A, I need B, I need C, and I need D. I then need to connect according to my edge set. So there should be an edge connecting A and B, A and C, A and D, and B and D. Graph number 4 has 5 vertices. We've got P, Q, R, S, and T. P to Q is my first edge. Q to R. R to R, which means I'm drawing a loop. Good. R to R is a loop. And then R to S, S to T, and T to P. Questions on those two? We've got what, 2 more? 2 more and then it's practice.
Does it matter where you put your letters at?
No,
No,
does not matter.
because I don't look.
What's your graph look like compared to mine?
Look different. I put mine right here.
Okay, that's fine. So, Jesus just said, do my points have to be in the same exact points yours are? No. Okay, that's the point I'm trying to get to. So he drew his in a different way. That's okay. His looks completely different than mine, but it's absolutely correct. Okay, there's nothing wrong with that, which is what makes these tests very difficult for me to grade because everybody's pictures look different. There's no right and wrong answer in this. Okay, all right. Graph number 5. It says I need 3 even vertices and 4 odd. So how many total vertices do I need? 7. Okay, I need 7 vertices because 3 of these need to be even and 4 need to be odd. Okay, unless they tell you that your graph must be connected, you can draw me a disconnected graph. Okay, that's probably the easiest ones to do when they're asking for even and odd, is to draw me a disconnected graph unless they tell you it has to be connected. Okay, so I need 4 odd vertices. So I'm going to pick 4 of these and make them odd. Well, if I just draw a line that goes from one to another and one to another, these are all odd. Okay, this has a degree of 1, this has a degree of 1, this is a 1, and this is a 1. Okay, so a single edge will make my dots an odd degree. If a single edge makes my dots an odd degree, what does a multiple edge do? It makes it even. So when I come down to these points, I draw multiple edges. And then I draw some more multiple edges. So this gives me a degree of 2, 4, and 2. So now I've got 3 that are even and 4 that are odd. Okay, my last one. Now you're seeing it's getting specific. So they want one that represents it that's connected and one that represents it that's disconnected. So I need 5 vertices. I'm going to draw all the vertices so you can first. Okay, so I've got 5 up there for my connected and 5 for my disconnected. So all you need to remember with your connected is make sure every point is reached out to by an edge. So the easiest way to do that is just connect the dots and go back to the beginning. So here's 1, 2, 3, 4, 5. I need 8 edges. So we can draw in a loop. There's 6. I can draw in a multiple edge. There's 7. I can draw in another loop. There's 8. Okay. So connecting all the points around the outside only gave me 5 edges. So I added in 3 more, 2 loops and a multiple edge. I need a disconnected one. So 1, 2, that's awful. Oh my goodness. Like completely awful. Let's try this again. One, 2, 3. Okay, so there's 3 edges. Now we're just going to keep this piece separate from that piece. So there's 3, here's 4. I can do a loop, that's 5. I can do a loop down here, that's 6. I can do a multiple edge, that's 7. I can do a loop up here, that's 8. But I still have 2 components. I've got this piece of it and this piece of it, which makes it disconnected. Any questions? Okay, your homework assignment is in Canvas, 5.1 through 5.3 worksheet. Okay, 5.1, 5.3 worksheet.